Hello everyone, this is Lab 2 Free Falling Object using two forces. The point of this lab is to observe, record, and analyze an object in motion as it is being affected by gravity and drag force. On the last report, we analyzed an object moving at constant velocity using Newton's second law. We found that for an object to have constant velocity, the net force has to be equal to 0. As we can see, we can plug this into the formula and realize that the final velocity is equal to the initial velocity. As mentioned before, on this lab we will analyze two forces acting on the object, making Fnet equal to 0. The weight force, which is weight, is equal to the negative of mass times gravity. The reason why it's negative is because gravity is going towards the Earth, therefore going in the negative y direction. The weight force is the force that pulls the object or system towards the Earth. The other force we're going to include later on in this lab is the drag force. The drag force is the force that pulls the object or system opposite to its motion, also known as air resistance. As the object falls, the air beneath it pushes it upwards, therefore making the object slow down. As you can see, we have the formula for the drag force, which is drag force is equal to b, the drag coefficient, times the magnitude of the velocity squared, times v hat, the direction. B, the drag coefficient, is directly related to the surface area of the object. Some basic tips you need to know about drag force are: 1. The faster the object moves, the greater the drag force. 2. The bigger the surface area of the object, the greater the coefficient of the drag force, B. Now let's look at the experiment. In this lab, I decided to have my friend drop a ball from a certain height. The ball was the system. Now let's look at tracker. I decided to have the system begin at origin 0, 0. As the system fell, it was going in the negative y direction. I tilted the axis a little bit in order to have the system fall in a straight line. The positive y-axis was to the top while the positive x-axis was to the right. From here, I was able to obtain all the information needed for vital. I plugged in the information into my code. The magnitude for the weight force G is equal to 9.8. J hat is the direction in which the system is falling, which will be placed as a vector 0, 1, 0. I changed the name of the CSV file, and on the calculation loop, I decided to add the weight force. We placed Newton's second law just like it was done on lab 1, but this time the net force is not going to be equal to 0. In order to know the magnitude of the forces acting on the system, we will use arrows, and we will code them like this. Once we run the program, we see the yellow arrow representing the weight force. For the second part of the lab in the code, we will change b, the coefficient of drag. I determined the coefficient of drag force b as shown in the lecture videos, by trial and error. In the calculation loop, we will add the drag force and the weight force together. We will also use arrows, and once we run the program, we see the blue arrow representing the drag force and the yellow arrow representing the weight force in the system. And now for the questions. The difference between the experimental graph and the model graph can be due to experimental error or force assumptions that were made. It can also be due to having more surface area and less density, or having less surface area and more density. Since there is no drag force, then there is no opposite equivalent force that will cancel out the net force in order for the object to reach terminal velocity. The model with drag and weight force reach the terminal velocity, and there is no change in velocity for a certain amount of time. Since the ball has more density and less surface area, then the drag force is going to be greater. A good example is if I had used a paper instead of a ball, then the paper would have fallen slower, and therefore will have more drag force than the ball. Now for the what if question. The initial velocity at which the ball is thrown is arbitrary. The velocity was changed to be initially at -10 because it exceeds gravity. Any initial velocity will allow terminal velocity to be reached. I changed the codes on Vital and found out that both graphs show the same meaning. The change in velocity in this case doesn't really matter. It will only matter if the system was on a slope.